Today we're starting section 1.2 and it's the basics of functions. So we're going to start with talking about function notation and evaluating functions, and then we're going to look at a graph and kind of dissect a graph that way. So for our first example, our function f of x equals x squared plus 3x plus 5. And we're going to give us three different values that we're going to input into this function. So remember, this is something we learned in Algebra 2 last year. F of x is a fancy way of saying y, and it allows us to input. So if I ever input something, I need to input it everywhere there is an x. So for our first one, letter A, we're going to evaluate the function at 2. So this means everywhere I see x, I plug in 2. So I have the quantity of 2 squared plus 3 times 2 plus 5. So 2 squared is 4, 3 times 2 is 6, plus 5. So when I plug in the value 2, my output is 15. So function notation allows us to get a coordinate pair if I want. So if I input a numerical value, my output will be a numerical value. So letter B, we're going to input an expression, a binomial. So now we're inputting x plus 3. So now I have the quantity of x plus 3 squared plus 3 times the quantity of x plus 3 plus 5. So this is where my FOILers, you need to FOIL, my boxers, you need to box. So whenever something is squared, that means there's 2 of them. I'm going to just move this equal sign over here so I have more room. So I recommend writing it out twice. Okay, so you know you have to multiply first, outer, inner, last, or you have to do the box with this or the distributing method. Over here, the middle term, I'm going to distribute this 3. So this will become plus 3x plus 9 plus 5. When I FOIL this together, I'll get x squared. My inner and outer terms will be 3x and 3x respectively. So that will combine to be 6x. And my last term is 9. And then I need to combine like terms. I can add this 9 and 5, and I can say it's 14. Nothing is going to combine with that x squared. My x terms, 6x and 3x, is 9x. And then 9 plus 14 will be 23. So when I input this x plus 3, notice if I input anything with an x in it, my output will also have an x with it. So my final answer is x squared plus 9x plus 23. All right, so one more, letter C. I want to input f of a negative x. So again, everywhere we see x, we input a negative x. It's important to use parentheses when you're substituting in a value, especially when it's a negative value. And then it was 3 times negative x, and then plus 5. So the reason it's important to put this quantity in parentheses is a negative x times a negative x would give me a positive x squared. 3 times negative x is a negative 3x, and then plus 5 does not change. So at this point we're done. There's nothing else I can do. There's no terms to combine with. So that's it for that. That's our final answer. The next thing that we're going to talk about is analyzing a graph. So here we have a graph about the T cell count in the HIV infection, which is your human immunodeficiency virus. So notice your x-axis represents the time of infection, the time after infection. So basically it's the number of years that's gone by after you get the virus. And your y-axis, which is f of x, represents your average T cell count. So the first question, letter A, says explain why this is a graph of a function. So explain why f represents a function. And the reason that this is a function is that this passes the vertical line test. So notice if I were to draw a vertical line anywhere on my picture, let me change my color. If I draw a vertical line anywhere on this graph, it's never going to cross more than one time. So that means it's a function. So your answer could say yes. Yes, it's a function because it passes the vertical line test. And again, this is something we learned last year in Algebra 2. Letter B. Letter B says use the graph to find f of 8. So they want us to find our value of f of 8. So what this means, after x is your input, so I'm inputting 8 years. So when x is 8, they want to know how many T blood cells, what our T count is. So notice right here is 8 years. I would go straight up, and I would find the y value that intersects with it. So I would say there's about 200 T cell count. After 8 years. Let me erase that. Oops. Letter C says for what value of x is f of x 350? So let me write this down so you get used to seeing this notation. So for what value of x is f of x equal to 350? So now they're giving you the output, they're giving you the y value, so we need to go to our graph on the y-axis. So 350 would be, so 300 is exactly halfway between 200 and 400, so 350 would be halfway between that. So we're going to kind of travel our way over, and notice it's going to be intersecting at 6 years, so the answer would be 6 years for this problem. And lastly, letter D, they want you to describe the general trend from the graph. So describe the general trend. Okay, so I'm not going to write this down, I'm just going to verbally talk about it. So if we were describing our general trend, some things that would be important to discuss is that this right here would be represents your first 6 months. So over the first 6 months, there is a rapid decline in your T cell count. Then the next phase we would say is right here. Over the next 6 months up to that first year, it appears as if you're starting to get better. Your T cells start to increase, at a rapid rate, but it will never go back up to what it was going to be. And then after that first year, there is a steady decline, and that will continue on until your virus finally turns to AIDS. So, and again, I'm not going to write that out, but on a test, I could give you a picture like that, and that is something that you would kind of discuss, the different phases of your graph. So that's all for today. We're going to pick up with this tomorrow.